Hello and welcome to week 11 of PUBH 612. Today we will be discussing choosing designs for effect evaluations. The learning objectives for this week are to select an appropriate design for an effect evaluation, to identify strategies to avoid possible threats to internal and external validity, to describe the pros and cons of different sampling strategies, and to explain the importance of sample size in assessing the effect of a program. This is a continuation of our lecture last week. When selecting the most appropriate design for your effect evaluation, you can draw on various disciplines, each which has their own terminology for describing designs. Psychology uses experimental and quasi-experimental designs, and it focuses on outcomes among individuals. And here you can see a typical outcome question used in the field of psychology. Are outcomes for individuals in the program different from those in the comparison or control group? The terms we've used so far in this course and throughout this lecture represent a blend of terms used in social sciences and epidemiology. In choosing a design, the aim is to come as close as possible to a design that can demonstrate an effect that was actually caused by the intervention, program, or policy. Here are some of the characteristics of an ideal design. First, the comparison control group should be as similar to the exposed group as possible. In randomized controlled trials, this is achieved by randomly assigning participants to either the treatment or control groups. But we don't always have the ability to randomize, so we need to try to make the groups as similar as possible. Second, the measurement of the outcomes should occur before and after the intervention. And third, there should be minimal threats to the internal and external validity. Here are some other design considerations. Causality is the first decision you should make. It's important for you to identify, if it's important for you to identify a cause and effect, aka a causal relationship. If it is, then you're going to need to select a study design that will enable you to show causality. And that will increase the complexity and the cost of the design in your evaluation. In whatever study design you choose, you will be trying to minimize bias, or the extent to which the study is flawed. External validity is the ability to generalize the findings to other populations, and internal validity is the ability to say that the intervention made the difference. You will also have to decide if your data will be collected retrospectively from the point of the intervention back in time. In other words, program participants will have been exposed to a program or policy before any pretest or baseline data are collected, or you could collect data prospectively, which is forward in time from a point prior to the intervention beginning. You'll also have to consider the time span of the evaluation and if data collection will be longitudinal with multiple pretests, post-tests over time, or if it will be cross-sectional. One survey or other data collection method that captures a snapshot of the population at that point in time. Other considerations are how you'll group participants into the exposed and unexposed groups, to choose which type of outcome you're going to evaluate, one which is unbounded by time or an event, and could have existed before and after the program, or the outcomes could be bounded, meaning that the outcomes can only occur once for any given individual at a particular time, and therefore are bound to an event in time. And lastly, the intervention could be at the individual or population level. Some designs are better suited to the individual level, while some are better suited to the population level. A population level change often takes time to manifest and for your intervention to show any effect, which means that the evaluation may require a longer time span. So these are just all things that you need to consider when you're developing your evaluation. Here you can see a graphic depiction of the relationship between the cost and complexity of the design and the ability to show causality. You can see that on the bottom left of the graph, outcome documentation such as post-test is not going to be able to show causality, but it's cheap and it's easy to conduct. While an outcome evaluation, which uses an experimental design, such as random assignment of treatment and control, is very costly and complex to implement, but it has a high ability to show causality. In program evaluation, experimental and quasi-experimental designs at the individual level are used when these four conditions are met. Information on the outcome exists before the program is delivered. Outcome information is available for members of 2 or more groups. The intervention is received by members of one of the groups, and after the intervention, data are collected from members of the same groups. An observational design, on the other hand, is best used for program evaluation at the individual level when the health outcome is bounded, such as birth or death. Please see Table 12-2 in your text for a summary of the main types of designs and their use for individual or population level evaluations. Most outcome documentation designs are non-experimental. Non-experimental designs are those at the individual level that involve collecting data after the intervention and comparing it to either the objective targets for the outcome or the pretest data. The designs you see listed here are popular because of their simplicity, which makes them easy to understand. But these types of non-experimental designs are weak and may not be able to attribute changes or differences that you observe in the outcomes to the actual intervention. These designs can tell you if a change occurred, but not if it was the intervention that caused the change. One group post-test designs only collect data from program participants after the intervention is over. This design is cheap and easy to implement, but has major threats to internal validity, such as history threats, which are when an event that happens to a participant between the beginning and the end of the program, as these events might actually explain your findings. Another threat to internal validity is maturation, which is when program participants mature physically or emotionally between the beginning and end of the program. Another type of design is comparison group post-test only, which collects data on both participants and non-program participants from the target audience after the intervention is over. The main threats here are attrition, which is the loss of participants over time due to death, moving away, being lost to follow-up, or dropping out of the program. And attrition increases as the lengthy time span for the data collection increases. It will probably be easier to find people for a follow-up survey, for instance, 1 month after an intervention than it will be 1 year after an intervention. Selection bias is also a threat in this design, and it refers to the fact that program participants may differ significantly from those that are not in the program. Selection bias is a tricky and important concept in epidemiology and public health, and it's critical to interpreting research, so please review this concept closely. Here are some outcome assessment designs. These designs for outcome assessment answer the question of whether any noticeable change or difference seems associated with having received the program. These designs are stronger than the ones that we just discussed for outcome documentation because there are statistical methods that we can use to adjust for differences between groups, and at the population level, it's possible to have a strong quasi-experimental design without a comparison group, such as a one-group time series. Each of these studies has their own unique challenges, so make sure that you select what is the best fit for your program and evaluation questions. Lastly, you can do an outcome evaluation research design, which, as we've discussed previously, will enable you to determine causation, but is the most costly and difficult to conduct. There are also ethical questions around random assignment. For instance, can you randomly assign one group to an intervention that you know is beneficial without offering that same program to the control group? Is that ethical? And the answer is no, not always. If not, you may want to consider something like a step wedge design where everyone in the intervention and control groups will receive the program but at different time points. Other practical issues with random assignment are you'll need a large enough target population so that you can select both your treatment and control groups from that one population. Also, the intervention must be robust, so in other words, the intervention must have a statistical probability of having an effect, and you'll need more resources like time, money, and expertise to conduct this type of evaluation. In summary, the key takeaways for this week are that every study design has its own pros and cons, and you just need to think through the possible threats to internal and external validity and what it will take for each study design so that you can select the most appropriate design and try to minimize these threats. Also, please be sure to review key epidemiology terms and concepts, such as confounding and selection bias and internal and external validity. Understanding these principles is critical. Lastly, remember to consider the feasibility of your evaluation design, because while in a random assignment and two-group pre-test, post-test may sound like the best option because of its ability to assess causation, it's not always going to be feasible or appropriate. Here are some additional resources that you can check out online, and please make sure to review any other materials on Blackboard. That's it for this week. See you next time.